Welcome to this lesson on justifying algebraic equations. The first thing I want to do is go over some vocabulary that we'll be using heavily during this lesson. A lot of these properties you probably have already learned in earlier math classes, but I want to review them to be sure you remember them because we're going to use them a lot. The properties of equality. So the properties of equality are important because if we have a statement that says two equations are equal to each other, or two expressions are equal to each other, if you do something to one of the expressions, you have to do it to the other one in order for them to remain equal to each other. All right, so let's look at some of our properties. This distributive property is not a property of equality, but it's used a lot when we solve algebraic equations, so I want to make sure we remember it. The distributive property says if you have a coefficient in front of a parenthesis, it's telling you to distribute that coefficient through, meaning multiply it to each item within the parentheses that immediately follow it. And so we have 5 times 3, that's where the 15 comes in, and then 5 times 2, so here you've got it. And you get your 15 and your 10. Those are like terms, so they combine to 25. All right, let's take a look at this other example. The 6 is being distributed through. 6 times 8 is 48. 6 times -4 is -24. Those are like terms, so they went ahead and combined them. Our subtraction property says if A equals B, then A minus C equals B minus C. What that means, it says if A does equal B, if I subtract C from the A, I must also subtract it from the B in order to remain equal to each other. So if 4 equals 4, then 4 minus 1 equals 4 minus 1 because I subtracted the same amount on each side. Our division property, we have two expressions set equal to each other. If I do something to one of them, such as divide by something, I must divide by the same amount on the other side for them to remain equal. So if 12 equals 12, and 12 divided by 4 equals 12 divided by 4. These are a little more simplistic to help you understand them a little bit better. Our examples will be involving variables, of course, because we're in algebra. The multiplication property. We start with our standard sentence. If A equals B, we're saying they're equal to each other. And if I multiply A times C, I must also multiply B times C in order for these to remain equal. Addition property. If A equals B, then A plus C, see these are opposites of each other, A plus C equals B plus C. If 2 equals 2, then 2 plus 3 equals 2 plus 3. And then one property that shows up occasionally is the symmetric property. If A equals B, then B equals A. You're just flipping it around. If X equals 2, then 2 equals X. You're just writing it in the other order, but it's one that we use often enough that I wanted to remind you of. All right, so keep this information handy because we're going to use it to justify our algebraic equations. So when I say justify an algebraic equation, I'm talking about proving to me why you're able to do the steps you're able to do to solve these equations. So I've given you a word bank at the bottom of all the equalities, and there's one here that we didn't talk about officially with the vocabulary term, but combined like terms we have talked about in the past. That's adding things together that belong together. So when we were talking about our distributive property right here, 15 and 10 were like terms and we combine them together. So that does get used occasionally on our justifications. So we're going to provide proof of why I'm allowed to do the steps I'm allowed to do to solve these problems. So all of these will be structured the same. This is a 2-column proof because there are 2 columns. The first line will always be the given problem. They're going to give you a problem, and if it's not written in, you'll write it in and write the word given here. That's the proof for that piece of information is I gave it to you. And we want to prove that x equals -4. So really what you want to do is you're going to solve this equation. And over here, we're going to write which property allowed us to do that piece of the information, that step, okay? So let's take a look. Really, you want to look this line to this line. What could they possibly have done? It's a little bit like a puzzle. So the 32 is still there, but the 12x is gone. the 4x changed into a negative 8x. What they really did is they subtracted 12x from each side. What allows us to do that is the subtraction property. All right. Now let's go. Now we're at negative 8x equals 32, and the next step shows x equals negative 4. Well, if you were solving this, what would you have done to get from this step to this step? X is alone. To get x alone, it's negative 8 times x. So if I want to undo that, I'm going to divide by negative 8. And I get x equals negative 4. What math did I do here was division. So what allowed me to do that was my division property. So that's a 2-column proof. You're going to tell why you are allowed to do each step based off of these vocabulary words. All right, so let's look at our second example. Here's our given. It's not written in, so we'll go ahead and write given. Now, let's take a look from this line to this line. Don't look at the rest of it. What is different between these two lines? Well, right here I see the minus 4 is gone from here. And I also see the 28 became a 32. That's because in solving this, they added 4 to both sides. Because 28 plus 4 is 32, and that cancels this 4 over here. Why are we allowed to do this? That is our addition property. Okay, now we're going to go from this step to this step. How are they different? Okay, well, I notice it's no longer 8x, now it's negative 4x. And on the other side, it's just 32. There's no 32 plus 12x. So what could have happened? What they did is they subtracted 12x from both sides. It canceled out on the left, leaving just the 32, and 8 minus 12 is negative 4. What allows us to do that is our subtraction property. Now, we just keep going with our same process. How did we get from this step to this step? I see now that x is alone, so they got rid of the negative 4 somehow. How would they have done that? It's negative 4 times x, so we're going to divide by negative 4 because that does multiplication. What you do to one side, you must do to the other. 32 divided by negative 4 is negative 8, and negative 4 divided by negative 4 is just x. That's our division property. All right, and then our final step, it said negative 8 equals x, and the next line it says x equals negative 8. That is our symmetric property. Remember when it said you can just change the order as long as you don't change anything else. So we're going to call this our symmetric property. All right, let's try our problem 3. This one is very short. So nothing's written on the first line. If you're not giving anything on the first line, that's your given, remember. Negative 4x plus 10 equals negative 5x plus 18. And that's our given. I want you to prove that x equals 8. So what is the difference between the first line and the second line? What changed? Well, I see the 18 became an 8. Interesting. Negative 5x is still negative 5x. 4x is all alone here. So this 10 got moved. It says plus 10, so it's a subtracting by 10 on both sides. And we're allowed to do that by our subtraction property. Now we're on line 2. How do we get from line 2 to line 3? Well, I see the 8 is still here. That means the 5x moved because it's not on that same side. So I'm going to add 5x to both sides. Negative 4x plus 5x is x. These cancel, leaving just the 8. We added to the other side, so that's our addition property. So if you take it just one line at a time, it makes it a lot easier. I recommend at this point stop before each of these to try them out and check to see how you did. It's a quick and easy way to see if you're picking up the concept. All right, our first line on number 4 matches our equation, so that's our given. We're going to prove that x equals -2. So when I look from first line to second line, I see the 51 is still there, but the 9x is not, so that means the 9x moved. It's a positive 9x, which means I must subtract 9x from both sides. That gives, I'm allowed to do that from our subtraction property. Okay, so 60 minus 9x, there's our 51. Our 153 did not change. And over here, the 9x is canceled out. Now, how do I get from line 2 to line 3? So I see the 51 becomes a -102. So something's happened on there. I see the 51x's are both still here, but the 153 is not still in line 3. It's plus 153, so I'm going to say minus 153 to cancel it out. And what you do to one side, you have to do to the other. And I end up with 51x equals -102. I'm allowed to do that because of our subtraction property. Now to get from line 3 to line 4, how are they different? Line 3 I see is 51x and line 4 is just x. So they undid this multiplication using division. Divide both sides by 51. The 51's cancel, and we're allowed to do this because of our division property. All right, 2 more. So we get a little more complicated as we go along. I'm going to write my equation in because that's how they all start. That's my given. Now, how do we get from line 1 to line 2? This is our distribution. You have a coefficient next to a parenthesis. It's telling you to distribute. -3 times x is -3x, and -3 times 2 is -6, and nothing happened on the other side. So this is our distributive property. Okay? Now, how do you get from line 2 to line 3? How are they different? Well, the 16 is the same, the x changed, and there's no x on the left anymore. So it looks to me like they added 3x to both sides, making those guys cancel, leaving just the -6. The 16 comes down, and -x plus 3x is 2x, and we're allowed to do that because of our addition property. Now, how do you get from line 3 to line 4? The 2x is still there, but that 16 has been moved. It's a positive 16, which means they had to have subtracted it. So that's our subtraction rule. And how do we get from line 4 to line 5? The x is alone, meaning we got rid of the 2, so we're going to divide both sides by 2. That's our division property. And finally, I'm left with -11 equals x, and I rewrote it at the end to x equals -11. That's your symmetric property. All right, let's try one last one. We're going to start with our given. All right, now, how is line 2 different from line 1? I still see the 12 is there, so nothing's actually happened on the right at all. So let's take a look at the left. What happened on the left? Well, it looks like they distributed the -2 through the parentheses, and we're allowed to do that because of our distributive property. Now line 2 to line 3. The 12 is still there. Okay, that means they didn't do anything on the right-hand side, but the left is different. When I look at this, I see, look at here, I've got an x term and an x term. So what they actually did is -x plus 16x is 15x. They did combine like terms. Okay. Now from 3 to this will be 4. We got 15x is still here, but that 18 is no longer on the left. It's minus 18. So we'll add the 18 to both sides. And we're allowed to do that because of our addition property. And our final step from 15x equals 30 to x equals 2, they got rid of the 15 next to the x through division. And we're allowed to do that because of our division property. All right, keep this close to you so you can refer to it while working on your practice problems.